Hi everyone, and welcome to today's Physics Daily Booster. This is number 14 in our Paper 2 series, and this is on the Advanced Information topic list for those of you doing Foundation Physics. It's not explicitly listed on the higher tier list, but as we know, questions are still likely to come up anyway. We are continuing with our work on the 8.2 section of the specification, so still looking basically at electricity. Starting off then, we need to know key facts, if you like, about mains electricity in the UK. So there are two numbers to learn, 230 volts, 50 hertz, and it is alternating. They have included this as a multiple choice question I can recall in the past, and I'm sure it's come up somewhere else as well, but I can't think where at the moment. So 230 volts, 50 hertz frequency, and it's alternating voltage. As we said in our previous booster, this is going to reach our houses through that network of power stations, cables, etc. called the national grid. So we've got two pictures here. The one on the left is showing an alternating voltage. Notice how we've got this little wavy line that goes positive to negative, etc. Whereas if we think about a battery, that has a direct voltage, and that is a horizontal line. So if ever you've just got horizontal line or something that's only in one region of the graph, that is our direct voltage. If you can see one that's a wavy line that alternates between obviously positives and negatives, that is an alternating voltage. The next thing we need to know about is something that I would class as a basic life skill. Your ability to actually wire a plug. Now hopefully you had a chance to do this in class. If not, then it's something that you should really pick up as a standard life skill, at least to take the back off a plug and change a fuse if nothing else, because it will save you a lot of money in electrician's fees or just buying new appliances when you don't need to in the future. When you take the back off a plug, you see this kind of setup. So we have got this thing here. This is our fuse. Now the fuse itself, actually, if you were to take it apart, has a thin piece of resistance wire running through the middle there. That means that if a current that is too high flows through it, the fuse wire is going to melt and as a result breaks the circuit. We then have three different colour wires here. So we have the blue one, which is the neutral wire, the brown one, which is the live wire, and the yellow and green stripy is the earth wire. So make sure you know the names and colours of our three different wires. Now ordinarily, if everything is working as it should do in our plug, then what we will find is there is a 230 volt voltage difference between the live and the neutral, and between the live and the earth wires. And there is a 0 volt voltage difference between the neutral and the earth wire. So in theory, that's what we should find if everything works absolutely fine. Now, what we find then is that the live and neutral wire are going to be making a complete circuit with the appliance itself, and our earth wire then connects to earth itself. The reason that we have our earth wire, the fuse, etc., is all to do with safety. If we were in a situation where the live wire has worked loose of its little connector, then we don't want 230 volts touching a metal case on an appliance, because if you then touch the metal case, you will be electrocuted and it won't end well. So instead, that earth wire connects to the case and obviously the earth pole that we all hopefully have connected on our homes. And that means that in that situation, it's going to actually carry the current through the earth and then out. So that means it's not going to be flowing through you, because the earth wire has less resistance than you do, and that current will take the path of least resistance. So it will just flow away and avoid you getting electrocuted. We mentioned the fuse with that little bit of resistance wire in the middle of it. So what we find in this scenario, if things are not going correctly, then the fuse is going to melt, breaks the circuit, stops the current flowing. So again, renders the appliance nice and safe. You will notice that there are some appliances that don't have an earth wire, even though they potentially do have some kind of connection to the mains itself. The reason for that is that they are what we refer to as double insulated appliances, and they'll have this little symbol on them. Now, this tells us that the case is plastic, and as a result there are no bits that current could flow through to you. So we don't need an earth wire because there are no bits of the case that could lead to electrocution. Therefore, double insulated appliances are all good without the earth wire themselves. As always, if there are bits from today's booster you'd like to go over in a bit more detail, you can use the P8 playlist on the channel, your revision guides, and do have a look at some of the past exam papers to get a feel for the kind of questions that come up. Then don't forget to join us once more tomorrow for our next Physics Daily Booster.